7.3 Multivariable linear systems. So in this lesson, we're going to talk about how to solve a system of three equations. This can be the main goal. So here's an example of a linear system with three equations. You see there's an x, y, and a z. We kind of keep them in columns. All the x's in column 1, all the y's in column 2, all the z's in column 3. Now, one of the best ways to do this by hand is to rewrite it in an equivalent system called the row echelon form. So it kind of looks like this step function, where it's like this. I always think about it like a triangle. You can see here, what makes this easy is that you know what z is. Z is 2. And then you can use that to plug into here to figure out what your y is. And then you'll use those two to plug into this one to figure out what your x is. So when you have a system like this, the kind of goal is to rewrite it in this form. I'm going to talk about how to do that. So first, let's do an easy one where, hey, we have it in this form to see how easy it is. Well, first, I got z, done. So now we're going to plug it back into here. So we have y plus 4 times 2 equals 7. So y plus 8 equals 7. Minus 8 minus 8, y equals negative 1. So now we have z and y. All we're going to do is plug all those into the top one. So x minus 2y, which we know is negative 1, plus 3 times z, which we know is 2, equals 9. So simplify first, x plus 2 plus 6 equals 9. That's x plus 8 equals 9. So minus 8 minus 8, x equals 1. So those are our answers. We have x equals 1, y equals negative 1, and z equals 2. We could write it in an order pair. It goes in alphabetical order, x, y, z. So 1, negative 1, and 2. That's our x, y, z. So that's how simple it is once you have it in row echelon form. Then it's like, oh, back substitute, you're done. But sadly, you rarely ever start that way. So what we can do is we'll start this way, and we're going to use what's called Gaussian elimination to get it to look like row echelon form. And all that is this. We have our, let's say our equations here, let's say A, B, and C. And what we want to do is make it look like a row echelon form. So we could do all the normal rules you can do when you try to eliminate equations, right? So you could like switch two rows. You could switch A and B or A and C, because it doesn't matter what's on top. It's just the way you list it. You could multiply a row by an equation, right? Like if I want to cancel out these y's here, I can multiply the top row by 3 and the bottom row by 2. It's like normal elimination. You can also add rows. So like once you're like, hey, the x's are going to cancel out, you can add them up and make that a new row. We'll talk about that. So like all the general rules you can normally do. You could switch rows. You could multiply a row by a number, as long as you do it to the whole row, and then you could add 2 rows to get a new row. So I would say that's all a fancy way of saying this. What you want to do when you have these is first eliminate the same variable twice. It does not matter which variable you eliminate, but you want to do it twice. And once you do that, you're going to get basically a 2 by 2, you're going to get a normal 2 by 2 equations. So then you just solve the 2 new equations. And then back substitute to find all variables. So that's like the general. So like that holds here true. So you want to pick a variable. A variable to eliminate, and then you're going to do it twice. So like here, they're calling out to us to eliminate the x's, right? So I want to eliminate the x's here. So what we're going to do is this. I'm going to add row A and B, because I know when I add them, their x's are going to cancel out. So the first thing I'm going to do here, I'm going to add row A and B. So I have x minus 2y plus 3z equals 9. That's my row A. My row B is negative x plus 3y plus z equals negative 2. A couple things. I like to label my rows so that I know what I'm doing. But also, it's very easy to make a small mistake. And it's very hard to find that small mistake once you do it. So try to be diligent while you do it to not like forget a negative somewhere or anything. So I'm going to add these two. The x's will cancel out. I would get negative 2y plus 3y is 1y plus 4z equals 7. Now, general rule here is this. You want to replace one of these equations with this guy. So how I'm working with A and B here, this should become one of your new A or B. We'll say this is my new B. Right, so that's our new B. Now we want to get rid of the same variable again. So we want to cancel out x one more time. You can do it with any two things you want. You can do it with these two. You can do it with a and c, whatever. I'm gonna do 2 times b, then I'm gonna add that to c. Right? If I times row b by 2, it's gonna become a -2 here, and I can add it to c and it'll cancel out. So that's what I'm gonna do. So 2 times b, so -2x plus 6y plus 2z equals -4, and then c is just 2x minus 5y plus 5z equals 17. Then we're going to add these up. The x's cancel out again. Ooh, I get a y plus 7z equals 13. Right? And the same rule, you want to replace one of the things. And in this case, I replaced b last time, so we're going to replace c this time. So right now I have an equation. If I could rewrite all of it, it would be a, then this would be my new b, and that would be my new c. But that's not Gauss. That's not row echelon form yet, right? It doesn't have two things. It only has one thing here. So this is where we get to my next step, right? So my first step was eliminate the same variable twice. So I'm like, you pick a variable. In this case, we picked x. We're going to eliminate it twice. So I eliminated it once, and then I eliminated it again using a different combination. Then next, we're going to solve the new equations. So we have these new ones here, right? We're going to solve those. So I have y plus 4z equals 7 and y plus 7z equals 13. That's my b and c. So what we do is we want to do the same thing here. We're going to eliminate a variable, and then we're just going to write that as one of our new equations. So here we're going to get rid of the y's again. I'm going to multiply some people like to subtract. I hate subtracting. So I'm going to multiply the bottom row by -1. So the y's here will be different signs. Then I'm going to add them. So I'm going to do this. -1 times c. I'm going to add it to b. So let me write it right here so you can see it. So b is just going to be y plus 4z equals 7. Then I'm going to multiply c by -1. I'm going to get -y minus 7z equals -13. Add these up. These cancel. Actually, I probably should have done -b. Anyway, I get -3z equals -6. And then we could have solved this, right? Divide by -3. Z equals 2. So that's going to be my new c. And if we want to rewrite it in Gaussian elimination, we could right now. So if we wanted to see it, my a was, I've not touched my a, right? X minus 2y plus 3z equals 9. And then my b is right there. My new b is right there. So b is y plus 4z equals 7. And then my c we just found out is z equals 2. Right, so that's written in Gauss elimination, right? All we did was eliminate the same variable twice. We went from here to here, and now this is easy to solve. We eliminated the same variable twice. Once we got our two new equations, we just solved it like normal, try to solve for a variable. And that's going to be one of our new equations. Then you just kind of rewrite everything, you're good. You're good to go. So that's if they wanted Gaussian elimination. Done. Most of the time I want you to actually solve the thing. So let's do that. Z equals 2. All we're going to do is back substitute. So I'm going to plug this guy into here. So y plus 4 times 2 equals 7. Y plus 8 equals 7. Minus 8 minus 8. Y equals -1. So now we have x and we have z and y. So we're going to plug both of those into our top equation here. I might need space. Let me try to shrink. Oops. Let me try to shrink all this so I can do it there. So we're going to plug them all into there. So we're going to have x minus 2 times -1 plus 3 times 2 equals 9. I'm just going to simplify. That's a 2. That's a 6. So I get x, it's a positive 2 I should say, plus 8 equals 9, minus 8, minus 8, x equals 1. So now we have all our things we need. It is a point, so x goes first, then y, and then z. Gauss elimination, right? So the general rule is eliminate the same variable twice. So you want to get rid of the same variable twice. The most common mistake is people get like, oh, it's really easy to get rid of x, then it's really easy to get rid of z. No. Eliminate the same variable twice. So whatever you decide to do, get rid of that variable twice. I'll get you two new equations, and then you just solve those like normal. So in this case, I got z equals 2, and then you just work your way back. So plug that equation into one of these to get your other variable. Then you have two variables, and plug it back into any one of the originals. If you want to make it look like Gaussian elimination, reduce row echelon form, and then you just gotta swap it out. So once you get to one of your new equations, make that your new b and c, and then once you solve that for your one variable, make that your new c, and then you get something that looks like that, and then you can back substitute if they want. So how about an inconsistent system? So we should go one that has no solution. What does that look like? Well, let's do this real quickly. We're gonna do the same rule. We're gonna get rid of the same variable twice. In this case, let's get rid of, I still say x is the easiest, right? So we have a, b, c. Let's get rid of this middle one here. So I'm going to multiply a by -2 so they cancel each other out. Then we're going to add that to b, and then sometimes we'll say we'll put that in b. Like, well, I should be doing this so notation so we know what's going on, right? I'm multiplying row a by -2, adding it to row b, and then we're going to put in row b after we're done. So let's do -2 times a. That'll be -2x plus 6y minus 2z equals -2. And then just b, 2x minus y minus 2z equals 2. We're going to add these up. These cancel. I get 5y minus 4z equals 0. So that's going to be my new b. Now I want to get rid of another one. Let's use these two to get rid of c. So I'm going to do a plus -1c and make that my new c. Right. So again, I could do -a plus c. Either way it works. Does not matter. So a is x minus 3y plus z equals 1. And then -1c. Again, I'm just doing that so I know what's going on. I'm going to multiply all of row 1 by -1. And then I can add them up and the x's will cancel. So I get -1x minus 2y plus 3z equals 1. Then I'm going to add these up. Those cancel. I get -5y plus 4z equals 2. Like that. So that's my new c. Okay, so my new c. And now what do we always do? Solve the new equations for each other. So let me run right here. So we have b is 5y minus 4z equals 0. And c is -5y plus 4z equals 2. Well, I don't really need to do anything. I can just add them up. Right? I could just do b plus c and put it in c or something. Those cancel. Those cancel, and I get 2. Well, just like before, if you get a false statement, that's no solution. If you get a true statement, then it's going to be infinite many solutions. So let's look at it, right? Just like when we do equation of normal lines, you have exactly one solution, you have infinite many solutions or no solutions. So it works the same way, even though if it's 2 variables or 3 variables with 3 equations. Independent, same thing. Let's quickly look at one that's infinitely many, just because it's slightly different. Look at how here there's missing an x and there's missing a z. We're going to do the exact same process though. We're going to eliminate the same variable twice. Now the one trick here is pick a variable that's already been eliminated. Let's say we do the x's like we normally do. So I'm going to eliminate x. Well, if you notice, this guy doesn't have an x. So I like to say it moves on to the next round. It's already my new b. So we have to use a and c to get rid of x one more time. So I'm going to go a plus c and make that my new c. Right? Because if I add those two, they're going to cancel out the x's. So you want to do the exact same way. Eliminate the same variable twice. In this case, I said x. Well, this guy didn't have an x. It got a free pass in first round by. So now you have to use these two to get rid of the x. So in here I have a is x plus y minus 3z equals -1. And then c is -x plus 2y. There's nothing for the z, so it's fine. Space or 0 if you want. Equals 1. Right, so let's get the space there. We're going to add them down. These x's cancel. Y plus 2y is 3y. That just adds down. So minus 3z equals 0. So we have this, right? If you really want to, you can also reduce it. You could like divide it by 3. If you want to make your life a little easier, we can always divide everything by 3. And we get an equivalent equation. So c is going to be y minus z equals 0. So that's my new z. Put that up here with the other new ones. And hopefully you can see they're the exact same equation. So when I eliminate them, they're going to cancel each other out. But let's just do it to make sure. So I'm going to do b plus negative 1c and get me a new c or something. Right, so my b I'll leave alone, y minus z equals 0. Right now they wouldn't cancel, so I need to make one of them negative. So let's multiply with negative 1 by c. So I get negative y plus z equals 0. You add, these all cancel, and you just get 0 equals 0, which is a true statement, so infinitely many solutions. So that's how it works. Okay, one more thing before we go. Let's look at what it looks like. Graphical interpretation. So these are 3D graphs. We're actually going to do this later on in the school year, but this is how a 3D graph looks. When you have an x, y, z, this is what it looks like, right? So you have the x-axis, you have the y-axis, and the z-axis. So what does it look like when we're solving these things? We're solving planes. So when you hit that intersection, you only have one answer. It looks like 4 planes crossing each other. When you have no solution, right, inconsistent, that means that all 3 don't cross. 2 could cross, but not all 3. All 3 don't cross out of a single point, or they're like this, or they're all on top of each other. They don't cross ever. And then if you have infinitely many solutions, then they're like all the same plane, or they all cross at like a line there. So that's what's going on. And that's the lesson.